with wireless networks, more connection-orientated, where we have layer 2 security. That's really not the case anymore. So part of the problem that caused was at upper layers, we had to have a tight couple in between a bunch of the system services. So DHCP and wireless had to talk together to make sure that we kept the state and the traffic that was going up and down through the stack was going at the right time. That's really not the best way to design it. So what we've done with NDIS ports is we ripple that information up and down through the stack. So NDIS port information includes the raw media connects, but it also includes information about power state and the authentication state. So now we have a much cleaner way to indicate up to system components what the state of that connection is. It now simplifies the design at the upper layers, and it also makes sure that there's much less chance for us to actually leak any information inbound or outbound before that connection's properly authenticated. So what can you mess with at the driver layer? The first one is you can actually do drivers. So previous versions, most people that wrote drivers are actually hardware vendors. In the Windows driver kit we've released for Vista, there's actually a full sample for a native Wi-Fi driver, for a wireless driver. This isn't just a set of code samples and functions. It's actually a fully functioning driver, and it works on real hardware. It works on the Realtek chipset. These cards are pretty available. In fact, our local CompUSA probably sells more of these than any other one in the country. You can take that driver, you can mess with it. If you want to do some 2.5 layer mesh, you could mess with the driver and do that. If you just want to do something malicious with 82.11 packets, again, you can modify the driver and do that kind of stuff as well. So there's a lot of flexibility in that. You've now got a real working driver on Vista. There's full code for it, and there's easily available hardware. Also worth noting, because it is the sample driver, although this is based on Realtek hardware, a number of the other vendors basically took that same design, so a lot of the other drives out there are very similar to it. Another interesting area to mess with is because we've now got that 802.11 layers natively open in the system, you can actually put filter drivers in there. So when you send a filter driver between the IHV mini port and the Microsoft driver, you can now see all the 802.11 traffic. You can see packet flows. You can see all the command and control stuff going up and down. Typical things you want to do with that is obviously any kind of protocol analysis. It's much easier now. And intrusion detection. If you want to do any kind of intrusion detection on the client, if you want to build, say, a distributed intrusion detection that works on all Vista clients, you can actually now get at that information. You can build those sort of tools on the platform. You couldn't do that in XP. So this is obviously a great toolbox for developers to play in, but it's not a free-for-all. You do need admin privileges to actually install drivers and to modify bindings. So this is, if you've got privilege on the box, you can do whatever you want, but it's not not exposing an additional attack surface. It gives you the ability to write attack tools on Vista, but it doesn't mean you can just go in and install a driver randomly on someone's box. So actually, we're now going to, Tarun's going to actually do a demo, basically some of the stuff we've done at that layer. We've knocked up some samples.
All right, thanks, Noel. All right, so Noel spoke about the enhancements that we have made at the driver layer, and I'm going to talk about one of the ways in which you can do it. I'll just do it by an example of writing a .11 packet sniffer. I bet a lot of you have used packet sniffers in your research. Some of you might be running it right now. This is a great tool just to experiment on Wi-Fi, to debug some hard-to-find connectivity issues at Wi-Fi, and just a good tool to do security research. So Vista makes it extremely simple to implement this tool compared to XP. And the primary reason for that is on XP, Wi-Fi integrated as an Ethernet media. So all the rich information, all the .11 packet headers and other state at the .11 layer was really lost. We had no idea of getting, or no way of getting it. But with Vista, because Wi-Fi integrates as Wi-Fi, so we can see the .11 headers, we can also see some rich information that is happening at the mini port layer. And as a result, you can write monitoring tools similar to the one that we are going to show right now. So the way I implemented this is like a filter driver, which sits on top of the native Wi-Fi mini port driver. And to get started quickly, I started with the sample filter driver that comes with NDIS WDK. I made two changes to this driver. First, I modified it so that it only installs on top of Wi-Fi devices, because we are interested in Wi-Fi here. I also modified the send and receive routines of this driver, of this filter, so that it makes copy of every .11 packet that it sees, and it dumps it to a file. To start capturing, it does a couple of OID calls down to the underlying Miniport driver, and that includes setting the driver to the required file type that could be 11A, B, or G, setting it to the desired channel on which you want to see the packets, also setting it to a new mode that we have defined for Vista. It's called the monitor mode, and setting a write packet filter. For the demo, I'm going to set it to indicate all the packets, but depending upon your needs, you can set it to whatever kind of packets you want to see. Once you have a capture, well, you can use different kind of tools to view it. We use Microsoft Network Monitor 3, but you can write your own custom application that can parse these packets and show it to you in a nice way. So what I'm going to do now is switch back to my Vista box and just take a live capture here. So just give me 1 second, I can't switch directly.
So you'd have seen this kind of stuff with Etherreel before. It's very easy to do this kind of stuff on Linux. On Windows, you'd probably have to install PCAP. You may have had to have specific hardware. There's only a certain number of drivers that will do this on Windows. And now with Vista, because this is actually part of the driver model, you can pretty much do it on any box.
I hope you can see that, yeah. All right, so what you see first of all here are the adapter properties. I have a Realtek adapter in my box, and you can see that the filter driver that I was talking about, it is installed on this. So just wanted to show that to you. I have also written a small tool called WL test. You can see it's reporting one wireless adapter here, which is Realtek. And let's take a... okay. Let's... do you know how to change the font here?
Just go down to one of those.
Yeah, I think this one should be fine. Is that better? Okay.
You can't actually see the screens from here. So
yeah,
really
that's why I can't change it to the... Let me just go back to this one. It's back to what it was. Is that okay? Can you guys see? Oh, okay, all right. I'll switch to the other one. Sorry about that. Oh, Lucida console. Oh, this one right here. Okay. And 16 or 20. All right, that's better. Thanks. Sorry about that. Hope that's better. Okay, so I have this small tool called WL test. All it's going to do is instruct the driver to capture packets. I'm setting it to mode 1, which is monitor or get all the packets. You can also write tools to just see the packets without disconnecting from anything, where you will only see the packets which are destined to your machine. So we're going to see every packet, so I'm setting it to mode 1. Let's set the file type to G. Let's set the channel to, actually I'm setting it to 0, which means it's going to scan over every channel, and it's going to stay on each channel for a couple of seconds. Say I can sit on every channel for 5 seconds, and let's collect the capture in foo.cap. So the counter that you can see at the bottom of the, I hope you can see that, at the bottom of the screen is the number of packets that we have captured on each channel, and it's going to stay, as I said, for 5 seconds on each channel and move to the next one. So we'll have to wait till it scans all the channels till 11. So while that happens, I wanted to point out that it's extremely easy to add this capability on Vista. It wasn't that easy on XP. And the primary reason for this is the way we have defined the driver model. For instance, the code that was required to add sniffing capability was like about less than 1,000 lines of code on top of the filter driver. Another thing which is really great about Vista is the fact that this capability can be done on any kind of Wi-Fi adapter. I know there is some kind of sniffing capability which is there on Linux and other operating systems, but they kind of are limited in the sense they only work with certain hardware. Here, all the interfaces that we are using to do this are standard interfaces. They're required for every device which integrates with Vista. So I'm just going to stop the capture because we've scanned all the channels. So once we have the capture, we can view it in any kind of packet monitor tool. I'm just going to load it in Network Monitor 3. Again, I'm sorry for the font. I'm not sure whether it's completely visible. So here, let me just try to increase it a little better. So this is the next version of Microsoft Network Monitor. Some of you might have used it on XP by the name NetMon. What you see here is a summary view where you can see a lot of interesting information. For instance, you can see the rate, the RSS, the rate at which the packet was received, the signal strength with the packet was received. So this is some of the rich information that we require every driver to indicate with the packet. And we have been able to capture this information along with the packets. And of course, you can look at regular .11 stuff. For instance, we have been able to capture data frames, control frames, and management frames. So let's go down here. Yes, so you can see management frames, control, and data frames. Then some other .11 fields just in the summary view, like CTS, RTS, beacons, Wi-Fi source and destination addresses, some other rich information about Wi-Fi. And of course, you can select a particular packet. Let me just increase this window. You can select any specific packet, and you should be able to go deeper into that packet. So say I'm going to pick up the beacon packet, and we can expand it further. If you guys are familiar with the .11 protocol, you'll really appreciate this. So there is some metadata along with this. Then of course the standard .11 fields like the frame control, the packet is to DS or from DS, source destination, BSS ID, sequence control, then the details of the beacon, the information elements in the beacon. So there is a lot of rich information here. You can see the rates so this is the BlackHat AP that Aruba has deployed for this conference. And you can see there are some mandatory rates that the AP is supporting. There are some standard rates the AP is supporting. It's also saying that non-802.11g stations are present right now. And of course, there is FCS of the packet. If you want to see the packet in raw format, you can of course see it on the right-hand side here. So the reason we use Netmon 3 here was again because in the new version of Netmon, it's extremely simple to add support for new protocols. The Netmon that we have right now does not have support for Wi-Fi, so I had to write a Wi-Fi parser here, but it was quite easy in the framework that they provide in Netmon 3. So I'm just going to quickly load up the parser here. So, well, the entire .11 parser, for instance, is described in the NPL language, and this is, I don't know if you can see this, but this is less than 1,000 lines of code again to write the .11 parser. So go check out Netmon 3. It's available on connect.microsoft.com, and it's also a great tool. So anyway, let's get rid of this. So once you have the capture, you can analyze it, derive some useful information out of it. You already saw a demo yesterday in the other device driver talk where they were able to look at the capture and in fact deduce what kind of hardware that Wi-Fi devices were using. I just wrote a small tool. It's just a toy tool. All it does is it's going to work on the capture file that we just took. That was foo.cap, and we are going to generate some kind of a graphical representation of it. So let's go ahead and launch this. So this was just out of the, sorry, let me just fix this here. This was out of just the 1 minute capture we took here. You can see there are 6 access points here. You can see which clients are associated with which AP. You can also see some other APs to which no other clients are associated. There's a Linksys and a Netgear, nobody's connected to that. You can see 2 ad hoc networks here. You can also see other 20 clients. You can see their MAC addresses, you can see what they are capable of, the channels that they are working on. You can see the networks that they are probing for. So for instance, you can see somebody with Tsunami and other networks that the different devices are probing for on the Wi-Fi network. So anyway, this is just a toy example, but the point I'm trying to make is that Vista provides a very rich platform for you to write a lot of monitoring tools. I mean, this you could have, this is not a lot of information here, but just an idea that you can build more monitoring and packet analysis tools and intrusion detection tools on top of Vista that will be able to identify whenever a Wi-Fi attack is in progress, or that will be able to identify some kind of attacks against the network or misbehaving devices on the network. So also suppose you do write these mitigation tools, you do write some intrusion detection tools on Wi-Fi for Vista. We also have very tight control over the Wi-Fi device drivers in Vista. So you can easily, or you can relatively easily mitigate against some of these attacks on Vista compared to any other operating system, including Windows XP. Just to give you an example, the number of interfaces that we have with